Paul, this is my first time here ever at Renishaw's HQ.
Me too, as well.
Yeah.
We're in Miskin, which is just north of Cardiff. Quite easy to get to from Cardiff. But yeah, this is a fabulous site, and I've got to say, I was expecting when I got here to see a lot of technology, a lot of machine tools, a lot of production, but I wasn't quite expecting to see as much as there is, and how kind of clean and tidy, and the environment around it's like, yeah, so commendable.
It looks so good. So here is one of their sites where, one of two, where they are making components for their own products that they sell.
Yeah, and I mean, we all know how challenging it is. You know, every day we talk to UK manufacturers, and we know how difficult they find things. You know, it's always about cost down. It's always about, you know, struggling to find labour and skills and all the rest of it. And these guys are no different. Even though you look at this outfit, it's no different. You know, they'll have the same challenges that any business does. So yeah, what we're going to see here today is about them investing in new methods and new ways to maintain.
I like that.
Maintain their business's position.
So let's treat this as a bit of a project as to what they've done, and they've found that they've gone for star machines. They're making components, aren't they? So why have they gone for the stars?
Well, let's walk this way, because I mean, when you look at the machines that they've installed here, and in fact there's more of these in Stonehouse as well. This is the SX38 machine, which is a really...
There's quite a few of them.
And it's a highly capable piece of kit. I mean, if you look inside this machine here, you know, you've got turrets, platens...
12 axes.
12 axes, 33 tools on here. I mean, it's some machine. And I thought what we're seeing a lot with this type of machine these days is people investing in them when they had maybe a vertical machining centre or a milling machine is where they were making a part previously, and it wasn't maybe as, you know, productive, or they had issues with the controlling the process, which is exactly what has happened here. And Star have come along, and you know, now with a bar feed where they can load up bars in the machine, and they can then machine what used to be prismatic parts on essentially a turning centre and do it much better as well.
So what's this triangle that they talk about then?
Okay, well, what's really interesting here is this is one of a family of parts, and this is what actually we've come to see. Essentially, there's around about 200 features used on this part, and it's machined on this SX38 machine. And again, if we look in the machine here, you can see you've got, you know, gosh, how many tools have you got in here, and how do you manage it all, and how do you have 33? Yeah, we've already answered that one. But how many axes have you got? So it's not just about reducing that cycle time, which is really important, and making the part fast. It's making sure that once it's reduced, the parts that come off are right every time. So what's really fascinating, and it gets more and more fascinating, because we both said before we came here, we always have a brief before we come to these jobs, and I looked at this brief and I was like, I don't quite understand, you know, what's happening here, what the process is. But actually, when you get here and you see it, which we're going to tell you now, is it all comes a lot clearer. So we have two blocks here. Essentially, we'll talk about this one, but this is like, they call it like a setting block, which is similar in some ways to the finished part, size-wise and so forth. And what this is that this is machined on the machine. And the reason they machine this is, well, they basically, once they've machined it, it's also got like a dot matrix thingy on here too. But and I can't exactly identify where that is, you might just see it on the edge there. But once they've machined it, this is where the Equator comes in. Let's go down to here. This part is then put onto the Equator machine, which then, of course, you know, analyses it, checks all the points, checks all the features, measures it, and then that information is then sent back
to the
we can do it's back to the SX machine, and what then happens is then they know that the machine is ready for production. So then the machine can run 100 of those finished parts that we picked up off, and they know that each one of those finished parts is going to be accurate because all the tool offsets are right. You know, everything within the machining environment is perfect. And then what happens is they'll machine another setting block that I just shown you after 100 parts, measure that again, and once they know that that's, once they take all the dimensions and it goes green on the Equator, they then run another 100 components. So essentially, their check is done on the setting block once every 100 parts, and then they can just keep running components, and that man only has to come here man or lady, I should say, come here for 7 minutes instead of an hour per shift. So it's an incredible saving. But the process control means the sub 10 micron tolerances across these parts with all those features. So you've got to control that with the volumes that they're making.
It's interesting that the setting block isn't the same as the final component though, isn't it?
I know, but the reason behind that is because you've got lots of different tools. You've got a roughing tool, a finishing tool, and you can't tell whether a roughing tool is in good condition because on a finished part, because the finishing part, you're not going to see it. So, there's all of these factors that mean that making that setting block is obviously, it's critical to the whole process. And like I said, before we came here, I was thinking, setting block, setting part, because in my day, when I used to make parts or make scrap, whatever it might have been, one of the two, you used to machine the first part, and then you'd tinker with the control, you'd change things around, and then you'd get to a finished part that was good, and then you'd run 100 off. But this has kind of flipped that, and and it runs out. And also the really clever part is you measure that setting block, you know exactly which machine the parts have been made on because they're all identified with these dot matrices. It's exceptionally
amazing, isn't it? It's
clever.
not just about the machine, but it's about the whole automation physically, but also through data.
Yeah, and you're going to see a lot of this type of thing because companies cannot find the skilled people. They cannot afford to have someone here for an hour every shift just monitoring, looking, checking. You just can't do it anymore.
Yeah.
So you need to find ways and methods. And this is like, probably going to take the words out of your mouth, but like a triangle.
Yeah.
Where you've got the machine and you've got the Renishaw Equator and then you've got Renishaw's Central, which is taking that data. And important to say that that data isn't interfering with anything on the machine.
No, it's all about
the NC. It's all about just the code. So, it's a fabulous solution. And now seeing it here, it really is very, very, very impressive. And I've got to say the guys at Star, who we do a lot with. We go to their open house, which they've got one coming up soon. They love the engineering side, don't they?
Yeah, they do.
I mean, Alec wouldn't mind me saying he's a real techie.
Yeah, and I love the fact that, going forward as well, if I'm honest, this is a bit of an element of survival, as in how can we go forward with technology, and it's having a project and a setup like this, which actually enables you to do that efficiently and
if I was a machine shop watching this, which there will be, I'd be looking, going, do you know what, how can I maybe adopt some of this mentality?
Not everything, it doesn't have to be everything.
No, but how can I, and more to the point probably, the sort of argument from a prismatic part to using it on a sliding head lathe. How capable is this machine to make parts that are, prismatic, square, rectangular? You don't need to, you've got to think differently.
Paul, are you impressed?
Really, really impressed. Really, really impressed. I think that it speaks volumes, really, about Star's engineering expertise is important. Equally, Renishaw's, the collective, the collaboration. Secondly, it's always good to see the SX38 and machines of this, capability.